we are to plot the points on graph sheet. Okay, but before we plot the points on graph sheet, I want to show you something. Okay, we have what we call interval or intervals when we come to graph work. Okay, and so based on, first let me write out the scale that we choose. Okay, so scale, for the scales that we choose, for the scale on the x-axis, 2 centimeters to 1 unit, isn't it? So 2 centimeters to 1 unit, because we counted in ones for every 2 centimeter squares. Okay, we counted in ones up to 10. And then for the y-axis, okay, we have 2 centimeters, that is for each full box or for each full square, 2 centimeters. 2, what was the unit we counted in? Counted in 10. So 2 centimeters to 10 units. To 10 units. Okay, that is the scale. Now, the next thing that we need to know is the interval or the divisions, what is known as the divisions. So, bear with me as I am moving the book around so you don't become distracted. So, divisions. What are divisions or what are the intervals? Now, look here. Between 0 and 1, between 0 and 1, or for each full square, okay, for each full box, how many divisions do we have? Let's count. 1. So we are going to count these small grids inside the full square. These small grids, or these small boxes inside the full square. We're going to count them, okay? So starting from this line, we have 1, 2, 3, 4, 5. Let me count again. We are starting from here because this is 0, right? So 0. So from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So between 0 and 1, we have 10 divisions. So each full 2 centimeter square for this graph sheet has 10 divisions or 10 intervals. Between 1 and 2, the same 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So in calculating for the divisions, normally I advise that you pick any two numbers from here. Don't choose 0 and 1. Sometimes they are consistent. At other times too, they are not, based on the scale you choose. Okay, so forget about here. Choose any two numbers. It could be 1 and 2, it could be 2 and 3, it could be 3 and 4, it could be 4 and 5. Now choose, I'm choosing 2 and 1. Okay, in between 2 and 1 are 10 divisions or 10 intervals, like we previously counted. Do you understand? And so to find each interval or to find each division, like this is 1, this is 2. But before we get to 2, from 1, what is the very next number here? Okay, what is the very next number here? Right up to here. What is this number? All we know is 1, here is 1, here is 2. All we know is here is 0, here is 1. What is the next number after 0? Is it 0.01? Is it 0.02? What at all is it? Here, is it 1.1? Is it 1.2? What at all is it? Okay, for each interval or for each division. So we need to know. Okay, so since we have already counted that here is 10, this is what we do. We take the larger number of the two numbers that we choose. Then we subtract the smaller number from the larger number. So watch me do it here. So I chose 2 and 1, right? So divisions, 2 minus 1. Okay, I subtract the smaller number from the larger number, and then I divide by the number of divisions or the intervals for one full square, for one full 2 centimeter square. And when we counted, they were what? 10. Do you remember? When we counted the small divisions or the small boxes, it was 10. And so you do 2 minus 1 divided by 10. 2 minus 1 all divided by 10. So this is what I've done. 2 minus 1 all divided by 10. And what do you have? 1 over 10. When you convert it, it is what? 0.1. This means that each interval or each division is 0.1. Okay? Watch here. Let's choose two sets of numbers again. Let's choose 4 and 5. Okay? We're going to get the same consistent divisions. 5 and 4, right? And we know that the individual divisions, the divisions between them, or the intervals, when we count it, they are 10, right? So let's choose 4 and 5. So what's the larger number? 5. You subtract the smaller number from the larger number. So 5 minus 4. Then you divide by what? The intervals or the divisions. 10. What are you still getting? 1 over 10, which is the same as 0.1. So each interval is 0.1. Okay? And so when we start counting 0, 0.1, 0.2, 0.3, 0.4, 0.5, because it increases by 0.1. Each division increases by 0.1. So here is 1. What is the next number right after 1? This division, this interval is 0.1, right? So it is 1.1. What is the next number after 1.1? 1.2. What is the next number? 1.3. What is the next number? 1.4. What is the next number? 1.5. So you keep on adding what? 0.1, 0.1, 0.1, 0.1. And so if you have here to be 5, okay, is it showing? If you have here to be 5, and what is the next number after 5? Add 0.1 to 5. Okay, so let's do it by calculation. You remember? Yeah. So 5 plus 0.1 is it, to make it more easier and simpler for us, because here is 0.1, we need to make here 0.0, right? So that you can just follow. So that is 0 plus 1, 1. Then you bring your points. That is 5 plus 0, 5. So the next number is 5.1. So here is 5.1. Then what is the next number after 5.1? We add the very interval we calculated for, which is the 0.1. We add the 0.1 to 5.1. So over here, 5.1. What is the next number after 5.1? We add 0.1 for the next division to it. 1 plus 1, 2. Bring your points. 5 plus 0, 5. So the next number after 5.1 is 5.2. 5.3, 5.4, 5.5, 5.6, 5.7, 5.8, 5.9, 6. Very good. So this is for divisions on the x-axis, right? On the x-axis, right up to what we did here. Now for divisions on the y-axis, okay? For divisions on the y-axis, remember each interval, okay? Each 2 centimeter square has 10 divisions, okay, or 10 little boxes, however you want to call it. Okay, so between here and here we have 10 divisions, just like here. Let's count: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's choose any two numbers. We could choose 20 and 10 for the y-axis. So y-axis, 20 and 10, we subtract the smaller number from the bigger number. 20 minus 10, then we divide by what? The 10 divisions. The 10 divisions. What is 20 minus 10? 10. So 10 over 10, we are getting what? 1. So this means that each division on the y-axis, okay, for distance measured in kilometers, each division is 1. Okay, or 1 kilometer. Okay, each division is 1 kilometer. Just like for the x-axis, each division is 0.1 letters. For the y-axis, each division is 1 kilometer. 1 liter. Okay, 1 kilometer. So see, each division is 1, right? So you add 1 to 10 if you want to get the next number. So here will be what? 11. You add 1 to 11, you get 12. 1 to 12, 13. 1 to 13, 14. 1 to 14, 15. You add 1 to 15, 16, 17, 18, 19, then finally 20. Now, remember how I mentioned that it is called a linear graph because the line follows after a straight path. We have non-linear graphs as well, non-linear graphs. But that is not the topic of interest now. We are only dealing with linear graphs. That is, graphs that follow after a straight line, okay, or that have their gradient constant. We will get there. But non-linear graphs, examples are scattered plots. Okay, so scattered plots where you have a coordinate plane like this, and then you have your scale, your calibrations here, and after you plot the points, okay, after you plot the points, you are getting what? Scattered points. They don't follow after a linear path. Do you understand? And so you have if say here is 2, 4, 6, 8, okay, and here is, then we have on the y-axis this scale that I've quickly written, okay. We can have, let's say this point, let's say 2.1 match up to say 13. We plot it here. When we come here, we can have let's say here 4.4, see, matching up to, let's say 11. You get it? And you can have this, let's say 7, matching up to, let's say 12. Okay, you can have here for these other plotted points, let's say here, okay, let's say here 5.8, matching up to somewhere 16. So the plots do not follow after a straight path. They are scattered in the coordinate plane. Okay, so there's an example of a non-linear graph. Okay, then we have quadratic graphs. Okay, in quadratic graphs, you can have a coordinate plane like this. Then you have, after you've plotted the points, you can have a shape like this, like a parabola. Okay, where this one passes through the origin O. It's not a straight line. It is non-linear. You can also have graphs like this, and the shape is something like this. Okay, something like this. It doesn't follow after a straight path, and so it is not a linear graph, but a non-linear graph. We are not treating non-linear graphs now. Okay, we are treating linear graphs. So this is just by the way.